Okay, so today we're going to take a look at 2.3 multiplying and dividing rational expressions. Now, this is a two-part lesson. We're just going to look at multiplying expressions today, and then on Monday we're going to get into the dividing. But everything that we work with today and on Monday is going to just be a continuation of where we've come from. So we've done some practice with factoring. We've looked at how to do non-permissible values, how to find our restrictions. And yesterday we looked at simplifying rational expressions. We also looked a little bit at equivalence. And today with the multiplying, it's going to be very similar to what we did with simplifying, but now we're going to put two expressions together. So the first thing I want to do is take you back to junior high. So if you remember grade 8 math, you were looking at fractions and we were looking at things like multiplying 2/3 times 1/2. And if you remember in junior high, when we wanted to multiply fractions, we multiplied straight across. So 2 times 1 was 2, and 3 times 2 was 6. And then we would reduce from there. So 2 over 6 became 1 over 3. And so we would reduce it. So anytime we were multiplying fractions, we just multiply straight across. Well, now we fast forward to 30-2 math. We're going to do the exact same thing, but now it's a rational expression, which means we're going to have some variables, which means we're going to have to do a little bit with denominators as well. So down the side here, I've got just some notes about multiplying fractions. Just like when we're multiplying fractions, we're going to multiply the numerators, multiply the denominators, and then we're going to simplify. You're going to state all your NPVs. Remember that usually you have to remember to factor first. Remember the F word. So factor first. Before we simplify, we got to state those NPVs, and then we can do any multiplying from there. So, well, I have this written as step by step. You're going to find as I work through this, I don't always follow them in the exact same order that I have them listed there. All right, so let's take a look at example number 1. We're asked to multiply x squared times 14 over 7 times x cubed. So we're going to multiply straight across. 14x squared all over 7x cubed. Now it looks just like what we had yesterday. And before we start canceling, we want to make sure to do our NPVs. X cannot be 0. Now we can hack and slash. Sometimes it might help to have a different color. And so we've got 14 over 7 is 2. And x squared over x cubed. Remember that if the exponent is bigger on the bottom or bigger in the denominator, that's where our answer is going to end up. So I'm going to cancel the x squared, and I'm left with a 3, or sorry, left with an x. So I'm going to have 2 over x, and my restriction is that x cannot be 0. Now, it comes to simplifying, there's more than one way to do it. So I'm going to show you a couple different methods. It doesn't matter to me which one you do. You're going to find some lend itself better than others. So some people like to just combine everything at once. They're going to have 12a cubed times a squared becomes 12a to the 5th. Remember, when we're multiplying powers, we add our exponents. And then in the denominator, we have 8 times 4 is 32, a squared. Now, 12 over 32 can be reduced. I'm going to show you a little trick. If you've forgotten how to simplify fractions, you have this handy dandy calculator right next to you, and you can put it to good use. So 12 divided by 32, if we math frac, it puts it into lowest terms for us. I'll show you that one more time. So 12 divided by 32, we hit enter, there's our fraction. There's our decimal. We want to leave this in fraction form as much as we can. So we're going to go math, frac is the first one, math frac is 3 over 8. So that means that when I reduce this, 12 is 3, 32 is 8, and a to the 5th over a squared, we're going to be left with a cubed. So we're going to have 3a cubed all over 8. All right, Joe, what did I forget to do? Oh, NPVs. You got it. All right, so I forgot to do my NPVs before I canceled. So I got to go back and look through that mess, and I can see that I had an A in the denominator. Or I can go up to the original and see I've got A's in the denominators. A cannot equal 0. All right. Now, how else could I do it? Well, I could also simplify the top and the bottom first in each individual bracket and then multiply them through. So if I have 12a cubed all over 8a, and I'm multiplying that by a squared all over 4a, I can simplify first. And again, if you're not remembering how to reduce fractions. You've got that little tool in your hands. Your parents have paid some pretty good money for that calculator, so might as well put it to good use. So 12 divided by 8, we math frac, and that is 3 over 2. Again, you could do that in your head and say, well, I'm going to divide both by 4. It's going to give me 3 over 2. And a cubed over a is going to leave me with a squared. These can get really, really messy, especially if you're not a very neat writer. So it's really important that you stay organized. So 3a squared over 2 and a squared over 4a, the a's will cancel, and we're left with a over 4. Yeah, I can hear you guys telling me I forgot my NPVs again. Gosh, I do that a lot. All right, so we've got a cannot equal 0. Now I've got this simplified. I can multiply straight across. 3a cubed all over 8, and a cannot be 0. Again, it doesn't matter to me which method you use. You're all going to get to the same answer. Now, let's look at ones that are a little bit more like what you're going to see in 30-2. Always, always, always remember that F word. Factor, 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 factor first. Get it as simple as you can, and then you can hack and slash. Remember that everything on the top is going to be multiplied by everything on the bottom. So we've got x minus 3. I'm going to put it in brackets. Remember, everything in the numerator is getting multiplied together, so I'm going to put it all together on the top. We've got 10x plus 50. I can factor out a 10. I'm going to put that in brackets, and that leaves me with x plus 5. In the denominator, I have x plus 5. I'm going to factor out a 7, and then I've got x minus 3. This is the point when we do our NPVs. So we're going to have x cannot be negative 5, and x cannot be positive 3. And now we do some hacking and slashing. Ooh, look at that, 10 over 7. Nice and simple. 10 over 7 is just our simplified expression. Even though there's no more variables in the denominator, our original expression had variables in the denominator, so we still have to consider our restrictions. So we have 10 over 7, and then x cannot be negative 5 and positive 3. Hopefully there were some lightsaber sounds out there. It's kind of hard to tell whether you're making noise right now or not. All right, I'd like you guys to try these 2 practice questions. Pause the video, take some time to do them, and then come back and check your work. And welcome back. Let's see what you guys came up with. So we have 4x minus 16. We're going to factor. We've got 4 times x minus 4. On the bottom, we're going to have a 7 and 2x minus 1. And then we have 2x minus 1. And when we have x minus 4 squared, sometimes it's easier to write that out as 2 separate factors. It's easier to see how we're going to cancel. Now we're going to have our NPVs. X cannot be 1 over 2, and x cannot be 4. Canceling out. Whether I have that time sign there or not, we are still looking at everything on the top being multiplied and everything on the bottom being multiplied. So some people start to think about this as cross multiplying. We are not cross multiplying. We are just canceling everything on the top, canceling everything on the bottom. If that is confusing for you, you can absolutely write it out as 4 times x minus 4 times 2x minus 1 all over 7 times 2x minus 1 times x minus 4 times x minus 4. Just get rid of that time sign in between. Sometimes it's easier to see what you can cancel. We can cancel the 2x minus 1s, and we're left with a 4 in the numerator and 7 times x minus 4 in the denominator. Sometimes in an answer key, you might see 4 over 7x minus 28. That is just an equivalent form. It means the same thing, or maybe on a multiple choice test, but I am completely fine with you leaving it in factored form. We've got 4 over 7 times x minus 4, and our restrictions, x cannot equal 1/2 or positive 4. Taking a look at the next one here, we've got 2x cubed minus 4x squared. So I'm going to factor first. I'm going to pull out a 2. I'm going to pull out an x squared, and that's going to leave me with x minus 2. And I also have an x squared. And then in the denominator, I'm going to pull out a 3 and an x, and that's going to leave me with x minus 3. And this is a difference of squares. Remember, 2 terms, there's only 2 options, difference of squares or GCF. So x plus 2, x minus 2. We take a look at our NPVs, and so we have x cannot be 0, x cannot be 3, and x cannot be plus or minus 2. And then we get out our lightsabers. Pachoo! Pachoo! X squared. Gone. And we are left with 2x cubed on the top. Make sure you don't miss that x at the end. And then we have a 3, an x minus 3, and an x plus 2. Now I know that doesn't look much simpler, but we still have canceled out some terms. And so we have 2x cubed over 3 times x minus 3 times x plus 2. With our NPVs, x cannot be 0, 3, or plus or minus 2. Now, moving on to part 2, we're going to take a look at dividing rational expressions. So I'm going to take you on a journey back to junior high again. Remember that when we were multiplying fractions, if I had 2 over 3 times 1 over 2, we multiplied straight across. So 2 times 1 is 2, 3 times 2 is 6, and then we reduced and got 1 over 3. When we were dividing fractions, though, if I wanted to have 2 over 3 divided by 1 over 2, then we had to multiply by the reciprocal. So we would flip. And so we would have 2 over 3 times 2 over 1, which gave me 4 over 3. We'll take a look at what would happen here if I had 2 over 3 divided by 2. Well, that's going to become 2 over 3 times 1 over 2, which gives me 2 over 6, which then reduces to 1/3. So when we are dividing rational numbers, we always have to remember to multiply by the reciprocal, and then we can still simplify. Now, that is very much the same when we're looking at rational expressions. However, it does have an impact on our NPVs. So if you remember a while back, I talked about our NPVs, all we care about is the denominator, and that's still true. But because we are multiplying by the reciprocal, what's going to happen is that second expression or that second term, when it flips, is going to change which term was in the denominator. So when I have a over b divided by c over d, that then becomes a over b times d over c. These two are going to flip. So the d is originally in the denominator, so it's still a restriction, but when we flip it, c also goes into the denominator. So when we're looking at the NPVs for a over b, our restriction is b. When we have c over d, then our restriction is d cannot be 0. But because we're multiplying by the reciprocal, we also have to consider c as a non-permissible value. So what I often tell students is to consider the L. So when we're looking at division, we have to consider everything in the denominator plus that c. All right, so that's written down here. We have to consider both the numerator and the denominator for the second fraction. Okay, and any variable that appears in the denominator at any stage in our process would be considered an NPV. So let's take a look at some examples. The first one here, we're asked to divide the following and then state all the NPVs. So we're going to have x plus 5. Some people find it helpful to put that over 1 times, remember we're going to flip this, x plus 9 divided by x minus 2. Once again, we consider our restrictions, and this is where I talk about using the L. So there's no restrictions for 1, but x cannot be 2 and x cannot be negative 9. So x cannot be negative 9, x cannot be positive 2. At this point, we see what we can cancel, and really in this case, there's nothing to cancel. So we're just left with x plus 5 times x plus 9 all over x minus 2. And unfortunately, that does happen. Sometimes things just aren't going to simplify. Taking a look at the next one, we've got x plus 1 over 3 divided by 3x plus 3 over 7. Well, I'm going to skip a step here. I'm going to factor and flip at the same time. So it's now a time sign. We're going to put the 7 on top. But when I factor 3x plus 3, I can pull out a 3 and I'm left with x plus 1. Now remember, we still have to do our NPVs. And so for here, I'm going to have that x cannot be negative 1. And I can cancel. So x plus 1 will cancel with x plus 1. And I'm going to be left with 7 over 3 times 3, which is 9. And my restriction of x cannot be negative 1. Now, why did I have negative 1? Because when I looked at my L, that x plus 1 does end up in the denominator. Taking a look at our next example, we're going to do the same thing. We're going to factor, we're going to flip, do our NPVs, and then hack and slash. So again, two terms, that means two options. This one is a difference of squares. So x plus 2, x minus 2, all divided by x minus 2. And then times, we're going to flip these, pull out a 4, we're left with 4 times x minus 2, and on the bottom, x plus 2. Again, we're looking at the L. So x cannot be positive 2, x cannot be negative 2, and those are our restrictions, plus or minus 2. Now in this case, it looks like we could have done some canceling even before we started multiplying across. We have an x minus 2 and an x minus 2 that are going to disappear, and we have an x plus 2 and an x plus 2. So we're just left with 4 times x minus 2, and our restrictions, x cannot be plus or minus 2. Again, you might see someone that writes that as 4x minus 8. Totally fine, but you can just leave it in factored form as well. Now we're going to take a look at another example here. Example number 3. This is the type of question that just kind of tests how well you understand how we can put expressions together. The first one isn't quite as tricky, but when we get into quotients, it can get a little bit tougher. So you're asked to write two rational expressions whose product is x plus 1 over 5x. That means that after we multiply our two expressions, our final simplified version is x plus 1 over 5x. But we have restrictions of x cannot be 0 or 3. That means that I have to have an x in the denominator and an x minus 3 in the denominator. And if you notice in my final product here, x is the only one that's left in the denominator, so that means that x minus 3 must have disappeared at some point. It's like magic. All right, so let's start by setting up our expressions. We know we have some fraction times some fraction, and we want to finish off with x plus 1 over 5x. When we're looking at products, we're multiplying straight across. So that means there has to be a 5 somewhere, there has to be an x somewhere, and there has to be an x plus 1 on top somewhere. We also know that an x minus 3 is going to disappear. So I'm going to maybe put an x minus 3 here and an x minus 3 here. And there's my expressions. X plus 1 over 5x minus 15 times x minus 3 over x. If I go through and do my canceling, I can check my NPVs first. I've got an NPV of 0 and 3. And when I cancel, I'm going to be left with an x plus 1 on the top and a 5x on the bottom. Now, certainly there are much more complicated expressions that you can do than that, but I like to stick to the keep it simple method. All right, moving on to quotients. With the quotients, it's a little bit trickier because remember that we're multiplying by the reciprocal. So my suggestion is figure it out as a product first and then work backwards to find the quotient. So we're looking for something that's going to multiply, because we're going to do a product first, multiply to be x plus 1 over 5x, but my restrictions are 0, 2, and 3. So I'm going to set this up again. We'll go back at the end and write it as a quotient. We're going to land with, or end up with, x plus 1 all over 5x. Now, I want there to be an x in the denominator, which there is. So we're going to have maybe the 5x here. But I have an x minus 2 that's going to have to disappear. So maybe I'm going to put an x minus 2 here and an x minus 2 here. And I have an x minus 3 that I want to cancel. So maybe I'm going to put an x minus 3 there and an x minus 3 here. So looking at my denominator, I've got an x, I've got an x minus 2, I've got an x minus 3. Everything will cancel out nice. Oh, I am missing an x plus 1. So I need to put an x plus 1 in there. So I'll put that right here. So I've got my x plus 1, these will cancel, and there I'm good. Now that is a multiplication statement, but it's asking me for a quotient. So I'm just going to rewrite it the other way. X plus 1, x minus 2 all over x minus 3 divided by 5x times x minus 2 all over x minus 3. The only thing that you want to be very careful of is where that x plus 1 goes. If I were to put that x plus 1 into the second fraction or the second expression, then I would have a negative 1 as an NPV. Since I don't, it has to be in the first fraction. Again, so this is just one example of many. Try to keep it simple as best as you can, but nothing stops you from throwing in some extra numbers as long as they cancel out and they don't affect your NPVs. All right, so I want to give you a minute to try a couple on your own. The first one is written as a division statement. The second one looks a little trickier, but if you remember that this is just a fraction divided by a fraction, and this is just a giant divide sign, it might be a little bit easier to figure out. So what I would encourage you to do if you're finding that expression, the way it's written, to be a little confusing, then rewrite it as a division statement. So 4x plus 12 all over 3x plus 12 divided by 3x squared plus 9x all over x plus 4 squared. All right, so take a minute to pause the video, try these questions on your own, and then come on back and check your work. All right, so first one's really nice to see everything is already factored. That makes my life so much easier. We can do our NPVs. X cannot be 3, X cannot be -5, X cannot be 0. And remember, because we're flipping it, we have to consider that X cannot be 2. So our restrictions, we've got -5, 0, 2, and 3. And the next step then is to write this out as a multiplication statement. So x minus 2 all over x minus 3 times x plus 5 multiplied by x times x plus 5 all over 2 times x minus 2. And then we get out those lightsabers. On the top, we're left with x. On the bottom, 2 times x minus 3. And our restrictions, x cannot be 3, -5, 0, and 2. Second one's a little bit trickier because we got to do some factoring first. We're going to pull out a 4, leaves me with x plus 3. We've got 3 times x plus 4. I'm going to factor and flip at the same time. X plus 4 times x plus 4. And then here we pull out a 3 and an x plus 3. And yeah, I can hear you guys saying it. What about your NPVs? That's right. NPVs, x cannot be -4, 0, -3. Oh, and look at that. The top ones here are also -4s, so we're golden. All right, let's do some hacking and slashing here. We're canceling out the x plus 4s. We're canceling out the x plus 3s. It's pandemonium. We've got 4 times x plus 4, and on the bottom we've got 9x. Again, our restrictions, x cannot be -4, 0, and -3. All right, that's all I got for you guys. If you got any questions, make sure you come in and ask for help. If not, have a great day, and I will see you soon.